Good morning, students. In this video lecture, we will learn the topic population growth and decay. The prerequisites to learn these topics are: you should know how to solve a separable differential equation, and the second one, you should know the properties of logarithms. These two are the requirements. So in differential calculus, the differential calculus is based on the notion of rate of change. It is observed in biology that the rate at which certain population grows is proportional to the number or size of the population at any time. In other words, the population growth is basically governed by the first order differential equation. So at any time, population growth means rate with respect to time t. So the formula for population growth will be, if n is the population at any time t, then the rate of growth, rate dn by dt, where n is the population at any time t, then dn by dt equals to kn. Here k is proportionality constant, and dn by dt is the rate of change of the population, rate of growth, that is proportional to the population at the time t, at any time t, so that is n. So dn by dt equals to kn. This is for growth, and similarly for decay, the formula will be same, but with minus kn, because decay means negative growth, so you will have minus here. That is a major difference. Later we will solve this differential equation, and we use the given data from the question, and we will find the requirement as per the question. So here, this is the first question. So let us solve this first question. So let us read the question. If the population of a country doubles in 40 years, in how many years will it be triple, under the assumption that the rate of increase is proportional to the number of inhabitants? So it's clear from this sentence, that assumption that the rate of increase, that is dn by dt, is proportional to the number of inhabitants. So here it is clearly increase, the word is there, so, and doubles, that means growth problem. So we will select dn by dt equals to plus kn, not minus kn. If it is a decreasing problem, decay or disintegration or decompose, for such words we will take dn by dt equals to minus kn. But here growth, increase, so plus kn. So let us write the formula first. dn by dt equals to kn as growth, and increase is there. So later if we solve this, clearly this is we can change this into a separable differential equation. 1 over n, I bring this n to down, dn equals to k dt. So clearly this is a separable differential equation, as you see dn and n, and here dt and k is a constant, of course, because here k is a proportionality constant. So clearly this is like the separable differential equation, and we know how to solve a separable differential equation. Separable differential equation, we need to integrate on both sides. So let us integrate on both sides. So let us integrate on both sides. We will get like this. So integral 1 over n dn, k being a constant, I can write outside integral dt. Clearly integral 1 over n dn is ln n, the rule from integration, kt plus c. Say this is equation number 1. Now at time and what is n given, we need to collect this data from the question. So at time t equals to 0, always we will take here 0 for any question of this kind. N how much? Always at the beginning how much is n that we need as the first step. So at time t0, n how much? Here you see, if we read the sentence, if the population of a country doubles in 40 years, that means population will become double in 40 years. After 40 years from now, the population will become double. But now how much? Not given. So at time t0 it is not given. So that's why time t0 not given. That's why we will take some it as n naught. So let us write t0 here. This will become 0 and n equals to n naught. Let us substitute here. So the result will be ln n naught 0 plus c. So this is equation number 2. Say so c is ln n naught. Let us replace this c with ln n naught here in equation 1. So clearly the equation 1 will become like this. Therefore equation 1, ln n same equals to kt same, but plus c. The c value is here ln n naught, so I wrote ln n naught, c ln n naught. So ln capital N minus ln n naught equals to kt. So ln n naught I brought to the left side of equal. Say this is equation number 3. Again we need the data, the given data at time t n how much. If we read the question, if the population of a country doubles in 40, this is the time. That's why this 40 years is the time. Clearly this is time. So time is 40 years. N will be how much? Doubles. So at time t0 already we have taken n as n naught. Now it becomes double. Double means multiplied by 2, 2n naught. So this is 2n naught as it is doubles. 2n naught, let us write t equal to 40 and n equal to 2n naught in this equation 3. Here n, here 2n naught, and time will be 40. So equation 3 will become like this. Equation 3 will be changing as ln 2n naught ln 2n naught minus ln n naught equals to 40k or k into 40. This is equation number 4. Next, for simplification, we will divide always equation 3 and 4. How to divide these two equations? Very simple. Just write ln n minus ln n naught. This is the left hand side of equation 3. Divide ln 2n naught minus ln n naught. That is the left hand side of equation 4. So and similarly, right hand side of equation 3, divide right hand side of equation 4, 40k. K get cancelled, and this is ln n divided n naught by the logarithmic formula. Ln m minus ln n is ln m over n. Like this, similarly down also the same thing. 2n naught divided n naught. Of course, these two cancel. Same. T over 40. This is the expression from which we can find the required data. In how many years? In how many years means time how much? Time we need to find time. Time how much? Will it be triple? That means n will be 3n naught. Triples. That's why 3n naught. So clearly here we'll take it is given that for n equals to 3 n naught for triple, how much time is required. So let us write this n as 3 n naught. So ln 3 n naught divide ln 2 equals to t over 40. The n naught is getting cancelled. Later simply ln 3 divide ln 2 equals to t over 40. So time t is, after cross multiplication with 40, ln 3 divide ln 2. We can find ln 3 ln 2 values with the calculator to get the final answer. That is the time required for the population to become triple. This is the second question. The rate at which a certain bacteria multiply is proportional to the instantaneous number present. That means dn by dt equals to plus kn, as multiply means increasing, not decreasing. If the original number doubles in 60 years, then when it will be triple. So it's the same type of question like one, so you can solve this as homework. So this is another question, the rate at which a certain bacteria multiply. So okay, multiply, clearly it is an increasing problem. Dn by dt equals to plus kn, that's why. Is proportional to the instantaneous number present if the original number doubles in 4 years. Okay, first of all I will solve by separable differential equation. This one, this is k dt. After integration, ln n equals to kt plus integration constant c as it is. Next step, always at time t equals to 0 n how much. By studying the problem, if the original number doubles in 4 years, original number will become double in 4 years, but now how much not given. At the time t0 beginning not given, say n naught, say. By writing time t equals 0 and n equal to n naught in this equation, we will get ln n naught times 0, 0 multiplied by k0, 0 plus c. This is 2, c value ln n naught I am writing here again in 1. ln n kt plus for c ln n naught here. So ln n minus ln n naught equals to kt. This is equation number 3. Clearly the next step we follow naturally. What about any given data again at time t and n? Let us see the question again. If the original number doubles in 4 years, this is the time, 4 years time. After 4 years, doubles original number we took as n naught. Now doubles means 2 n naught as it doubles. So let us write t equal to 4 and n equals to n naught in equation 3. So the equation 3 will become ln 2 n naught minus ln n naught as it is here for t 4k. So 3 divide 4 ln n minus ln n naught divide ln 2 n naught minus ln n naught equals to kt divide 4k, k and k get cancelled. So with the logarithmic formula, ln n divide n naught ln 2 n naught divide n naught equals to t over 4, and these two also cancelled. Let us read the question again. Then what should be their number at the end of 12 hours? So this is time t given. We need to find n how much. So given time is given as 12 hours. So take time t equals to 12. How much is n. So let us substitute in this expression ln as not given, ln n not given, ln divide ln2, but time is given as 12. So here for t, let us substitute 12. 12 divided 4, this is 3. So ln n equals to 3 ln2 after cross multiplication. And later the next step will be very with the logarithmic properties. Ln n equals to ln 2 power 3, m log n, m will go here. Ln equals to ln 1 ln 1 ln, both sides get cancelled always, so n equals to 8. Here we forget one item, that is n naught. So ln divide n naught. So here n naught. So the last step will be n divide n naught, n divide n naught. So n equals to 8 n naught. So 8 times the original number will be there after 12 hours. So like this we can find it. That is population growth. So here the next question, if you read radium decomposes at a rate proportional to the amount present. Decomposes, the word decompose, that means clearly dn by dt equals to minus kn, because this is decreasing, not plus kn. And after that, let us solve the separable differential equation. 1 over n dn minus k dt. Clearly it is a variable separable differential equation, as we can solve with the integration concept. That is ln n integrating minus kt plus c. See, this step is common every time. Later time t0, always time 0 in any question I am taking. N how much? For first step, if 100 milligrams reduced to 90 milligrams in 250 years, that means initially at time t0, at the beginning, it was 100 milligram. After 250 years, it become 90 milligram. So let us substitute these two in equation 1. ln 100 times 0, so this will become 0. C, this is 2. Let us write this equation 2 in 1 again. So it will become clearly ln n equals to minus kt plus c value ln 100. So with that you'll get simply ln n minus ln 100 equals to minus kt, say equation number 3. Later again, at given time, what is n from the question? If you see the question, if 100 milligrams reduced to 90 milligrams in 250 years, time 250 years, and n 90 milligram. So this is clearly time, and this is n. Let us write time 250 and n 90 in equation number 3. ln time 250 and 90, 250 years, this was 90. So ln n is 90 minus ln 100 as it is, minus k, and time is 250. So this is equation number 4. As usual, we will divide equation 3 and 4, which leads to ln n minus ln 100 divide ln 90 minus ln 100 left hand side over left hand side, and right hand side over right hand side. These two cancelled. Ln n over 100 by the property of logarithm. Ln 90 over 100 t over 250. Now let us go to the question again. Determine how much will remain at the end of 500 years. So time is given, we need to find n. Time 500 years. So at a time 500 years, and how much? So let us write in this expression ln n over 100, no change, ln 9 over 10 because here 0 cancelled, and for time t it is given as 500. This is clearly 2 times. So ln n over 100 equals to ln 9 over 10 after cross multiplication. So ln n over 100 ln 9 over 10 square. Ln cancel, because here 2 is there, we cannot cancel ln, but now we can cancel as ln and ln are only single alone. Later from this we need to find n. Clearly n by 100 will be equals to 81 over 100. Clearly these two get cancelled, so n equal to 81 milligrams. This much will be remaining after 500 milligrams. So like this we can solve this decomposition or decay problem. So let us take another question. The radioactive substance disappears. Disappears means it is decreasing. So negative growth, that is dN by dt equals to minus Kn, minus important. So next 1 over dN minus dk dt as it is integrating minus kt plus c. These steps are common. Next at time t equals to 0, this also we will take like that, always time 0 starting. If half the original amount disappears in 1200 years, that means initially how much not given, so say n naught. So after substitution ln n naught, 0 plus c, c will be ln n naught. Let us write this here. So equation 1 will become ln n equals to minus kt plus ln n naught. Ln n minus ln n naught minus kt. So at time t equals to n how much? Again it's the step 2 always. If half the original amount disappears in 1200 years, this is time clearly. So 1200 years, sorry, here time 1200 years, 1200. Half the original amount disappears. The original amount is n naught. Half means divide 2. So this will be n naught divide 2. This will be n naught divided 2 because half. So this is n naught divide 2. Let us write this time t here and n here in this equation 3. Equation 3 will become like this. Ln n naught say minus k t is 1200. So this is equation 4. Generally we divide equation 3 4. So ln here ln n minus ln n naught divide ln n naught by 2 minus ln n naught minus kt minus k 1200. These two getting cancelled. So here next we need to find the last what is the requirement, then how much will disappear in 200 years. So time is given 200 years, this time is 200 years. How much will disappear, and we need to find. So it's the mathematical expression ln with the property ln divide ln l naught, logarithmic property ln n naught by 2 divide this n naught t over 12 hand, right? So this is the expression in which we need. So time 200 years, how much will disappear, n we need to find. Time is 200 years, so time 200 years and how much. So let us write these two in the expression here. 200 divide 1200, 0 cancel, 1 over 6. Later ln n over n naught is 1 over 6, and this will be cross multiplied, from which we need to find n. Ln n over n naught, ln 1 over 2 over 1 over 6. With that ln cancel, ln equals to n naught 1 over 2 1 over 6 is the final answer. This we can find with calculator also. So this is today's topic. This is today's in this video lecture we learned this. So let us have a review. So law of growth and decay we studied. Population growth, for growth plus kn dn by dt equals to plus kn. For decay or decompose or disintegration, minus kn. We will take a separable differential equation. We have to solve by integrating that one. Later always here we take time t equals to 0 and n equals to original number. If given, we will take that. If not given, we take it as n naught. Later we take the given time and given population, we substitute the equation, we divide the equations. Like this we will proceed. So that is the end of this topic.